Hi. Testing. Those of you in the outer hallway, come on in. I think we got a great couple speakers here for you to listen to. Go on and continue your conversation, but please come in from the hallway, and we'll fill up the seats. I always say that everybody must be Methodist or Baptist because they're not using the front two rows. So you can come down closer if you like. Promise. I think maybe we should take business cards from everybody in the first two rows and give away some type of cash prize. Oh yeah, we got a winner here. Okay. Okay. We'll let a couple more people get in. Amanda, everybody coming in? All right. Well, let's sort of get started here. Good morning. I'm Steve Berry, President and CEO of Competitive Carriers Association. And on behalf of everyone at CCA, I want to welcome you to our 2017 Mobile Carrier Show. First, a special thanks to our Pinnacle sponsors. For this year's show, it's Ericsson, Huawei, Interop Technologies, Nokia, Sprint, T-Mobile, and TNS. Your sponsorship is much appreciated, and we sorely appreciate it, and really do thank you for your support. So I do hope that we had a chance to enjoy the Fierce Wireless breakfast this morning. Very interesting panel sponsored by T-Mobile, so thank you, T-Mobile. And also, if you're able to attend one of the seminars that just completed, sponsored by thought leaders of our industry, hope you had the chance to do that, and we'll have a chance to visit some more this afternoon. A special greetings to those who are joining us by webcast this morning. RCR is our broadcast partner, so RCR Wireless, thank you for the webcast. So in the interest of keeping the momentum going and keeping us on schedule, I think I'll just introduce our first speaker. And our first speaker comes to us from Ericsson, a longtime member and strong supporter of CCA. Ericsson has been doing some remarkable things, and thanks to its unique focus on smaller and medium-sized regional markets, Ericsson continues to provide innovative services to CCA carrier members. And I should also point out that we're very pleased to have Ericsson's Amy McCune on our board and our executive committee, where she's doing a fantastic job for everyone. And this morning we are honored to have Ericsson's Gowton Achaibar. I think I got that right, Gowton? Okay. He's head of the strategy and technology for Ericsson's North American region. He is responsible for defining and driving Ericsson's technology and company strategy in all of North America. Gowton comes to us with a great deal of experience in the mobile world. Previously, he held a position as head of IT and cloud at Ericsson, and he has served in various positions over the years with the company, actually for over 10 years. So with a decade behind him at Ericsson, now gives me great pleasure to introduce our first speaker, Gowton. Gowton, after you. Thank you. Thank you.
Good morning. Can you hear me? I've got 20 minutes to talk about the hottest topic in industry, so hopefully I share some insight that's useful. We titled this On the Road to 5G because our thinking in Ericsson is that 5G is not some isolated event that will happen at some point in time that will replace 4G or make 4G obsolete or somehow kill off the whole 4G networks that we have today. In fact, we see opposite. We see a very synergistic interaction between 5G and 4G, and the ability for the two technologies to enable each other to serve their specific use cases much more effectively. And so our view is that this is a natural advancement of where we are today in terms of our technology roadmap and the use cases that we're serving our customers. But I'll start with a view from a customer standpoint. So from an end user standpoint, we know that mobile data growth is accelerating, especially with unlimited plans, but more importantly with the proliferation of video over mobile and the impact that the OTT players have had on mobile networks as they push out video solutions. So the video over mobile, together with the unlimited data plans or creating large data in the mobile growth, large mobile data growth. We also know that the traffic is shifted. It's no longer just outdoors, it's outdoors and indoors. Whether it's consumer or enterprise, you have to serve both the outdoor need as well as the indoor need. And we also know that customer experience is changing, not based on just their interaction with their carriers, but also with the interaction with a lot of the web players. If you're a web player customer, you hardly ever call customer support. You pretty much will go to the website and look up whatever information you need on whatever service you're purchasing from that player. And the speed of service deployment is also something that is impacting networks, because the OTT guys are able to add and remove services very quickly, and ultimately cost is important. So what we see is that there is a transformation happening across multiple domains or multiple aspects of the network, access networks, going from broadband to ultra broadband. So, from serving 30 or 40 megabit to gigabit. Core networks evolving from nodes to SD-NFV cloud type architectures. The IT environment being transferred from specific systems into more of a digital environment where data becomes an important aspect or an important output of how you run IT. Because if you can become more data driven, I think you can become a more effective company, because now you're using data that you can actually parse and do something with, and it gives you more intelligence about what's happening in the business. Operations moving more to customer experience orientation versus the traditional alarm management, performance management, network planning. Because if you take a VoLTE network, for example, a customer may terminate a call, and the network statistics will argue that that's a normal termination. The customer will argue that the call was terrible, and that's why they terminated. And the reason why is because the problem did not exist in the RF domain, where statistics are usually looked at. It existed somewhere in the layer 2 or layer 3 protocol in the IP layer. And then ultimately, we think monetization models will go well beyond the individual. And if you look at the way we see 5G developing or evolving, it's no longer about, if you argue that so far we have been trying to build telecom networks to meet the needs of consumers, whether we're providing them voice or data or short messaging or MMS, in the future, the 5G networks will probably be defined and designed more to provide industries and other types of verticals solutions that they can leverage. I think we're moving into the era where 5G is much broader than just a solution for the traditional consumer. And so if you look at the evidence for that, we have done some research together with some partners which shows that machines will outpace humans, and by 2021, you could anticipate that there will probably be about 15 billion IoT devices versus, let's say, 13 billion human connected devices. And the opportunity is also increasing quite quickly and quite rapidly because of this explosion of connected devices being an integral part of the network. So clearly, 5G is more than just the type of service we provide today. We actually categorize it into 3 buckets. The first bucket in the lower part of this slide, where we talk about enhanced broadband, that's pretty much to serve some of the current use cases that we have today, where end users are already up to 5, 10, 15, 20 gigabit of usage per month. And so you need a much higher bandwidth type solution with more spectrum to serve those high capacity needs. So fixed wireless access tend to be the first use case in this bucket. The second area we see a set of 5G solutions is what we call massive IoT. So the ability to connect an end user machine or a IoT device to the network. Here, we could probably do that today. In fact, we can do that today with 4G networks with CAT-M that has been released already, and narrowband IoT that is coming towards the end of this year. And so in this type of scenario, it's lots of devices. It's just a matter of getting the right coverage and the right power for these devices. And then there's a third category that we're terming critical IoT. Here we see the need for the concept that we have talked about in the industry around network slicing, where one application may need a very low latency, for example, autonomous cars, to allow a car to stop almost instantaneously, whereas another application may need extreme security. And so you can create a slice that delivers low latency for an application that needs low latency, or a slice that delivers an application that needs high security, or a slice that delivers an application that needs high bandwidth. So the concept of critical IoT is also important in terms of the way we're looking at how systems have to be designed and managed in the future. So 5G is not just one application, we break it up into these three buckets. And what it drives also is not just rethinking around network, it also drives a rethinking around business models. Because today, a lot of the operators have business models that are, you can say they're subscription-based. They're monthly bills or some kind of a prepaid solution. In the future, you probably have to also have a transaction-based model. You may also have to have a model where you can subsidize the user. So a third-party company, an industrial company, may want to offer a solution to all their endpoints. Let's say they build tractors and they want to collect the data from every tractor. So they'll be willing to pay for the connectivity to those tractors because the data they collect, they can process and they can do something with that data that will enhance their own business cases. Whether it's, ensuring that the owners of those tractors can come in for routine maintenance, or they can identify issues that are occurring that they can proactively do something about. So I think these subsidization type models will also become part of how we need to look at 5G. So it's a business model issue, and then ultimately it's how do you transform the network to be able to adapt and deliver on all of these broad set of services and applications. So it's two aspects to rethinking the models that we're looking at today. Now I talked about the mutual benefits of 4G and 5G, and I thought I would share this with you because this is a simulation that we did. And this simulation shows that if you take a 4G system at low band and you integrate it with a 5G system at high band, and you let the 5G system do what the 5G system do best, which is to handle capacity, and the 4G system to do what the 4G system does best, which is to handle mobility and coverage, you can improve the performance of the combined two technologies by a factor of 13. Now, I don't have enough time to go into the details around this, but certainly we have this kind of a data, and we could share and discuss how we see this happening. But it's really about letting the 5G system, because it has high bandwidth, to take away the capacity spike that might be in a 4G network. And once you take away the capacity spike from the 4G network is now able to operate and behave a lot differently. And so we see this coexistence of the two technology create a 1 + 1 = 3 type of dynamic as you build a system with both. Now, in terms of the actual evolution then, what has to evolve in terms of the network? If we take the access first, we see that the access evolution today could start using some concepts we're discussing in 5G. So if we take the first concept, massive MIMO, where you're actually creating beams in the network using very high density antenna systems, you increase the capacity of the network significantly. In fact, I was commenting to someone this morning that back in 1995, the concept of smart antenna and beamforming was already being discussed, except the antenna looked like the size of that door. And so while the concept made a lot of sense, the practical application of it didn't make much sense. And in those days, we were trying to solve the high band problem, which the high band problem was 1.9. So it became clear that the concept was interesting, but it wasn't practical, not from an application deployment standpoint. But now massive MIMO systems are very practical. We're building, if you get up in frequency at 28 gigahertz, for example, the antenna is with 512 transmit and receive antenna is about this size. It gets integrated into the radio. So as you go up in frequency, the possibility in how you can use massive MIMO type antenna improve quite significantly. And even at lower frequency, we're building with the advancement technology antenna configuration that makes sense to deploy in a 4G system. Multi-user MIMO, the concept of using time and frequency resources for multiple users using the same beam. The idea of RAN virtualization, because as I said, if 5G and 4G systems will eventually be coexisting, then there are aspects of the RAN network that you may want to extract and virtualize because those aspects of the network will be used for both radio technology. And so with the advent and proliferation of virtualization and distributed cloud, these virtualized RAN become very much a part of that thinking. And so that you can control the two networks, the 4G and 5G, from the same set of parameters, whether it's layer 2 or layer 3, in a virtualized RAN environment. Latency reduction is another aspect of 5G that we're looking at implementing in 4G, and there are some techniques that we're using now to see how we can reduce the latency in a 4G network. And then intelligent connectivity, we're already doing this in 4G through, you can say, carrier aggregation, where if you take let's say a higher band, 2.5 or 3.5, and combine it with a lower band below 1 gigahertz. If you can use carrier aggregation, what you essentially do is you extend the coverage area of the high band because you manage the uplink limitation of the signal. And so if you can manage the uplink limitation of the signal, or you can manage the signal in the low band of the spectrum, you can use the two bands to manage the data more effectively. And so intelligent connectivity between low band and high band, between 4G and 5G, is an essential aspect of how you would design a next generation system to be able to leverage the spectrum resources most efficiently. And so these are all, you can say, aspects of 5G thinking that we're now bringing into our 4G type of design and solutions. In the core network, there's also a set of concepts here that is important. The most important one is the idea of transitioning from networks today that are very node-based. So if you have a node from one vendor, software, middleware, hardware integrated, a node from a second vendor, and you run out of capacity from the first node, you can't use the hardware in the second node because they're individual node from individual vendors. In a 5G world, to provide network slicing, you want an environment where you can provide software upgrade into a platform that's a common platform, so that you can take different slices of different software, create one end-to-end solution, and deliver that solution to a 5G application, or even in a 4G world. And so the concept of virtualization, software-defined networking, distributed cloud are all being discussed today and are actually being rolled out into networks today, because it transforms the network from this very restricted node-based construct into a more programmable platform-based solution. And it allows much more flexibility. And when you add to that the ability to do analytics and ultimately some kind of a machine programming or AI, you all of a sudden can automate your network, not just in terms of how you create and deliver an end user service, but also how you do management, performance, and operation. And then if you take it one step further and you open up the API, you can also now create vertical solutions across the network for specific industries or verticals. So we see a fairly significant transformation happening in the core to go with the radio network. And that transformation has already started. I think the first white paper on virtualization for telco networks were released back in 2013 or 2012. So this is not a new concept. This is something that has started, and we're moving along this path. And it's essential to when we get to a 5G environment. So just to wrap this up then, just to summarize what I want to leave with you, is that the first thing is the use cases will be well beyond consumers. I think if we have built networks for the last 150 years to serve the needs of consumers, we're at the break point now where we need to think of the business somewhat differently. It's going to be consumers, of course, but it's going to be more than that. Which means that the participants in the industry will broaden significantly. In fact, I think every industry and every player will participate in the ICT industry going forward, because it is the next technological revolution that will have a significant impact on business performance, efficiency, and margins and so on as you go forward. So I think you will see a broader set of market participants in the industry, and 5G is one other trigger that will drive it. I think you will see multiple monetization models. As I said before, it's not just about subscription models or prepaid to consumers, it's also about transactions, also potential for subsidization of revenue or subsidization of the service from a third party. The internet guys do that very well with advertising today, but our industry can do that as well going forward. And then definitely there's transformation across all network domains, whether it's access, core, IT, all of it will be transformed somewhere, somehow going forward into the future. Okay, so that's all I had. Hopefully I shared with you some ideas and concepts that is meaningful, and I thank you.
Very good. Thank you, Gowton. We're very fortunate that Ericsson is so involved with many of our carrier members, and